Today we're going to be going over Vieta's formulas. However, this is going to be the basic video that only concerns integers and it's going to be only about quadratics. I'll make a future video with higher order polynomials. So the one that we're going to be looking at today is just a quadratic equation in the form of ax squared plus bx plus c. So Vieta's formulas basically state this. The sum of the two roots of an equation like this is going to be negative b over a, and the product of the two roots are going to be c over a. So I can show you this with an example. So in the equation x squared plus 4x plus 3, that factors to x plus 1 times x plus 3, right? X plus 3. Okay, so the two roots here would be negative 1 and negative 3. So now if we apply Vieta's formula to this equation, x squared plus 4x plus 3, the sum would be negative 4 over 1, because this is b, the a is going to be the imaginary 1 here. It's going to be negative 4 over 1, or negative 4, and the product is going to be 3 over the 1, the imaginary 1. So it would be 3 over 1 is equal to 3, because 3 is the c, and 1 would be the a. So it would be 3. So now we can check that with the roots that we got from our equation, negative 1 and 3. Let me change this to white. Okay. So if it's negative 1 and 3, the sum would be negative 4, as we got here with our equation. And our product, negative 1 times negative 3 is 3, as we got over here. So now let's try to do a problem with Vieta's. Let r and s be the roots of 2x squared plus 4x plus 13. Compute 6 over r plus 6 over s. Okay, so before we learned about Vieta's, we would just straight out bash this problem, right? 2x squared plus 4x plus 13. And we wouldn't see any way to factor this, so we'd use the Pythagorean theorem and write out the big formula and all that, but yeah, let's not do that this time. So now we're going to use Vieta's formula to solve this problem. So let's look at this. 6 over r plus 6 over s is equal to, now let's try to make this into a form that we can use Vieta's in. So 6s plus 6r over rs over rs, right? So what I did here was just multiply the whole thing to get a common denominator. So now we can combine because we have like denominators. So 6s plus 6r over rs. Okay, and now we could factor the 6 out. So 6 times s plus r over rs. Okay, so now we can use Vieta's, because Vieta's is for the sum and the product. So let's erase everything that we don't need here. We only need that 6 times the s plus r over rs. Okay, so now let's plug in our formula. So let's write down here the sum is negative b over a, and the product is going to be c over a. So negative b over a, so let's write down a, b, and c. So a is going to be the coefficient of the first term, which is 2. B is going to be the coefficient of the second term, which is 4. And c is going to be the final term, which is 13. Okay, so now let's plug these in for our sum and product respectively. The sum is going to be negative 4 over 2, or negative 2. And the product is going to be 13 over 2, because c over a. So now if we plug these in here, we get 6 times the sum, which is don't want that. 6 times the sum, which is -2 over 13 over 2, which is equal to -12 times 2 by 13, or, let me just write this up here, -24 by 13. That's our answer. So now we learned how to solve a problem and solve for the sum of the roots without even finding the roots, which is going to be extremely useful in all kinds of middle school competitions and in your high school curriculum.